Hello friends, in today's video we are going to see about the properties of metals. Please see, if you see this heading, the properties of metals. As we know, metals possess various mechanical properties, physical properties, chemical properties. So we are starting with the mechanical properties of metal, and which is very popular in the industry for manufacturing and for developing a new products. These mechanical properties plays very important role. So let's see without wasting time. So guys, please see, we are going to see the mechanical properties. So first let me tell you, there are 12 mechanical properties I have mentioned here. I have bring you for you guys. Please see, the first one is strength, second one is elasticity, third one is plasticity, fourth one is ductility, fifth one is malleability, sixth one is toughness, then seventh one is hardness, eighth one is hardenability, then brittleness, fatigue, creep and stiffness. So all these are the mechanical properties of material. All these names, that is strength, elasticity, plasticity, ductility, malleability, brittleness, fatigue, creep, stiffness, all these are the mechanical properties of materials. So let's see them in detail. Now in this slide you can see I have just make one slide which is easy to understand for you guys, that here I have mentioned the at the center, that is mechanical properties of materials, and all the around are the surrounded are the mechanical properties of material. Please see, that is hardness, toughness, elasticity, plasticity, ductility, malleability, stiffness and brittleness. So all these are the mechanical properties of material. Now let's start with the strength. Now guys, strength means what? First of all, I would like to explain you to this image. Okay, you can see there is a one rod which is loaded with some loads. Okay, and there is a one palm is shown here that lift that entire rod, loaded rod, just on one finger. So it means that its strength means your, what we say, strength means nothing but your capacity, okay, to sustaining any load or to lifting any load, like that. Okay, so let's see what do you mean by strength is. So it is the ability of metal to resist external forces without rupture or destruction. See guys, what do you mean by strength is? Strength is the ability of metal to resist external forces without rupture. Rupture means breaking, without rupture or destruction. Okay, suppose any external load or external force is going to be act on a metal. Okay, so strength defines the ability of that metal to resist that force applied or load applied on it without breaking. Okay, if your material broken down, then it means your load is going to act beyond its ability to sustaining that load. Okay, if you are loaded any material beyond its capability to sustaining the load, then your material will be broken down. Okay, so strength means what? Strength is nothing but to resist. It is the capability or ability of metal to resist the externally applied forces or loads without breaking or destruction. Okay, see, the stronger the metal, the greater the load it can withstand. See guys, what this sentence tell us, the stronger the metal, if your metal is strong, then greater the load it can withstand. If your metal has high strength, then it can withstand, it can sustain a very high load. Okay, it is termed as shear strength, tensile strength and compressive strength. There are three different types of strengths are there. What are these? Shear strength, tensile strength and compressive strength. Okay, so this is all about the strength. Strength is nothing but the ability of metal to resist externally applied force or loads without breaking or destruction. Now in this slide I have brings for you two different mechanical properties, that is you can see here elasticity and plasticity. Now let me tell you first elasticity. See guys, what it is, let me tell you about the picture first. You are seeing one picture. In this picture, okay, that rubber band is stretched by two hands or two fingers, and here it is written as elasticity. Okay, so now how elasticity is defined? It is very easy. You can see I am just reading this definition. Please see, a metal is deformed when acted by external force or load. See guys, what it is written, a metal is deformed when acted by external force or load. Now let me tell you what do you mean by deform means. What is the meaning of this word deform? Okay, deform means what? Deform means deformation. Okay, deformation means whenever there is external load is acting on your metal, okay, that because of that external load your metal is going to be deformed. Deform means your metal is going to be change its shape and size because of deformation. Okay, so that phenomena, because of externally applied load your metal going to change its shape. So that shape changing phenomena because of your externally applied load is called as deformation. Okay, so what it is written here, a metal is deformed means a metal is changes its shape and size when acted by external force or load. Okay, it is correct. So elasticity is the power of metal. See guys, elasticity is what? Elasticity is the power of metal to regain its original shape and size and after deformation. Please see, elasticity is the power of metal to regain its original shape and size after deformation when the load causing it is removed. Okay, when the load causing it is removed. Elasticity refers, if suppose let's take an example, if I have applied force on any of the material and because of that virtue of that load my metal is deformed means change its shape and size. So if my metal possesses elasticity, okay, if that metal possesses elasticity, then what happens, as soon as you remove the externally applied load your metal is going to regain its original shape and size because of elasticity. Okay, so this is nothing but the elasticity. Now plasticity, let me tell you first, plasticity is extremely, okay, exactly opposite to your elasticity. Okay, we know that elasticity is the power of metal to regain its original shape and size when the externally applied load is removed, is termed as elasticity. So plasticity, what I have told you, plasticity is exactly opposite to elasticity. See guys, what do you mean by, let's see what do you mean by plasticity is, it is extreme opposite to the elasticity. I have told you earlier. See guys, it is extreme opposite to the elasticity. It is that property of metal due to which it retains the deformation or shape made on it even when the force causing it is removed. See guys, it is extreme opposite to the elasticity. It is that property of metal due to which it retains the deformation. Retains means it holds the deformation. What? Retains means it's holds means पकड़ के रखना है ना. It holds the deformation. Deformation, you know very well, the change in shape and size of the material because of externally applied load. Okay, now see, plasticity refers to the permanent deformation of metal. Okay, if you loaded any metal and because of that load your metal got deformed, it means your metal changes its shape and size. But as soon as you remove that load, in case of plasticity, as soon as you remove that load, then also your metal doesn't regain its original shape and size because your metal is gone to the plastic deformation, okay, to the plasticity, or that is why it doesn't regain its original shape and size after removal of externally applied load. Okay, that is the plasticity. So plasticity refers to the permanent deformation of material or metal. Okay, what do you mean by permanent deformation? In permanent deformation, your metal doesn't regain its original shape and size even removal of externally applied load. So this is the basic difference in between elasticity and plasticity, and I think I hope that you understood this. Okay, now see what is the next property. Now similarly I have two more properties of mechanical properties of metal, that is ductility and malleability. Please see, if you see my cursor, ductility and malleability. So guys, let me tell you what do you know ductility is. Okay, first of all we should discuss about this image which is shown here. Okay, ductility means nothing but it refers to the tensile load. Okay, ductility refers to the tensile load and this malleability refers to the compressive load. Okay, this malleability refers to the compressive load. Now see how it is refers to the tensile and compressive load. Please see. Now what do you know ductility is? See guys, ductility is that property of a metal. Ductility is that property of a metal due to which it can be drawn out into thin wire without rupture. See guys, ductility is that property of metal due to which it can be drawn out into thin wire without rupture. Okay, you have seen so many metals in a wire form. If you see copper wire, which is used to conduct electricity. If you see metal wire, okay, ms wire, so all these are the copper is a ductile material. In my video, that is I think unit number 4, that is copper and its alloy, we have seen copper is a ductile material. Why we say copper is a ductile material? Because copper is a material which possesses this ductility property, and what it tells us, ductility is that property of a metal due to which it can be drawn out into thin wire. Your metal can be drawn out into thin wire without rupture. Okay, example is your copper wire, which is used to conduct electricity, and this is very common example. I think all of you have seen that. A ductile material must be both strong and plastic. Okay, a ductile material must be both strong and plastic. Now that is why I have told you earlier that ductility refers to tensile property. Okay, if you want to increase the length of any metal, okay, any metal, so that metal should possess ductility, because what it tells, ductility is the property which is allow the material to form into thin wire. So how your metal is going to be formed into thin wire? By applying tensile force on that metal. Okay, if you apply tensile force on that metal, then and then only it is possible to convert your metal into thin wire form. Okay, so that is why I have told you ductility refers to tensile force. Okay, and ductility is the property of metal due to which your metal can be drawn out into thin wire. Example is copper wire or mild steel wire. Now let us come to the malleability. Now see malleability. Now here I am talking about the image first. See guys, metal hammered into thin sheets. See guys, this is hammer. Let us see, this is hammer, this is your gold, this is the material which is called as gold, and this is, you can see, gold coin. Okay, this is what? Gold coin. Now you can see, please see here, this is hammer, this is gold, and this is gold coin. So by hammering this gold, or hammering means by applying compressive loads on this gold, you can see your gold is going to convert into coin form. See guys, converted into coin form. So this is what malleability is, and it is written here, gold is the most malleable metal. Please see what it tells. Please see, malleability of a material is its ability to be flattened into thin sheets. See, malleability of a material is its ability to be flattened into thin sheets without rupture by hammering, pressing, rolling, etc. Okay, malleability of a material is its ability to be flattened into thin sheets without rupture by hammering, pressing, or rolling. So that is why I have told you earlier, malleability refers to compressive forces, because what malleability tells us, malleability of a material is the ability of material to be flattened. Flattened means to be formed into thin sheets without rupture. For example, your plates, steel plates, gold jewelry, gold coin, okay, all are the examples of malleability. So ductility refers to tensile property, that is, it is the property which allow your material to be drawn out into thin wire form. And what do you mean malleability? Malleability refers to compressive property. What? Malleability refers to compressive property by the virtue of which your material going to be formed into sheet form. Okay. Now let us see the basic difference between ductility and malleability. Now what is the basic difference in ductility and malleability? Please see in this slide. Please see guys, what is the first point in ductility? Ductility is the ability of a material to undergo deformation under tension without rupture. I have told you that ductility is a tensile property. Okay, ductility is the ability of a material to undergo deformation under tension without rupture, whereas malleability is the capacity of a material to withstand deformation under compression without rupture. Okay, then second point in ductility and malleability, please see, it is the property of a material by virtue of which it can be drawn into wires. It is the property of by virtue of which material can be hammered or rolled into thin sheets. Okay, about malleability. So ductility is a tensile property and malleability is a compressive property. It is very clear. Then fourth is, ductility depends upon the grain size of metal crystal and malleability depends upon the crystal structure of material. Okay. Then examples of ductile materials are mild steel, copper, aluminium, zinc, nickel, tin, and examples of malleable materials are gold, silver, aluminium, tin, zinc, wrought iron, etc. Okay. So you can see in the fifth point, that is in example point, some metals are ductile also and even malleable also. Okay, see these materials like aluminium, zinc, okay, these are what, ductile also and malleable also. So all these are the some mechanical properties of material. In next video we are going to see another rest of the mechanical properties. Thank you.